Hello, Adit. I'm audible. Hello, Adit. Is it audible? Okay. So, Adit, look, we'll be starting with. Okay, we are done with the result with the last class itself. So, I told you to go through the parallelogram and triangle law better. Have you gone through that? You are not audible properly, Adit. Okay, great. So, look, if you are done with the parallelogram and triangle, then it's fine. Or else, I'll just go through that. Okay. So, what is the thing we have to study? That is vector addition. Now, the topic of discussion is vector addition. So what we can simply do is, we have two ways of the vector addition. Assume the first case, when you are given two vectors, so you teach till addition of triangle. No, no, I didn't teach just addition of triangle and parallelogram, I guess. Did I? I teach till resultant. I had to teach triangle law and parallelogram law today. Is it? Okay, so I will start with the vector addition. Okay. Parallelogram and triangle is the follow of the part. Okay. The main is analytical method, which we will do at the last of these three methods. The first is normal method. Assume you are given two vectors which are parallel to each other. Okay. One main property is that if two vectors are parallel, if vectors are parallel, then their direction is also same, is equal, right? Direction basically unit vector is equal. So if I this is a vector, this is b vector. What is addition of vector? Basically, I'm doing a plus b, right? What does this mean? I'm going to do a vector plus b vector magnitude, and I am taking the direction common because they are both same. So this is the resultant of a parallel addition. Okay, that's fine. So you can simply, if you are given two parallel vectors, let's say 5i plus 7i. Okay, different. How you can add both of them? You can simply just add their magnitude and say that the resultant is 12i. Okay? This is the thing. If A is this and B is this, then you will get the resultant as 12i. That's another is another is as if they're this is the case of parallel. If they're anti-parallel like this, so you can simply do the reverse of it. Instead of adding the magnitudes, you can subtract the magnitude. Okay, let's say A, this is B. So what you are going to get the resultant? Basically A plus, that is okay. The direction is opposite. Okay, are you getting it? Direction is opposite, so you can say the magnitude of A minus magnitude of B will result to some direction I. Yeah, kind of A plus I minus B as a magnitude part. If I just have to do, so you can say that this is 5i, and this might be like in the previous direction, so I have to write it as 3i. So you can say this is 2 times of I. That's fine. Let's move to the next main important thing I'll cover from here onwards. Main is triangle's law of vector. What does the triangle law of vector says? Law of vector addition basically. It says that if two sides of triangle, if two vectors, if two vectors represents the two side of two consecutive sides of triangle, then the third side will represent represented by the reverse of the resultant. Okay. So look very carefully. I am saying this is one side. Okay. I am saying this is another consecutive sides. Okay. These are two consecutive sides. So let's say this is A, this is B. So you know what is going to be my third side? This is going to be my third side. Can I say this? But the question, as per the triangle law of vector addition says that if two vectors are representing A and B are representing two consecutive side of triangle, then the third will be represented. This is a third, okay. This is going to be represented by the reverse. Like this is going to be represented by the reverse of resultant. So assume this is the reverse of the resultant. So what is the resultant? The resultant should be this. Clear, others? Okay. Just look at the definitions once again. We will get it properly. So don't get confused with this part. I am saying that if two vectors A and B they're in consecutive nature, mean to say head ends a new tail starts. Basically from here new state starts, tail start. Okay. So this is how you will be getting the consecutive sides. So when I say the consecutive sides are there, the third will be represented. This is the third. Okay. This is going to be represented by the reverse of resultant. It means whatever this is nothing but the reverse of resultant. But what I need the resultant, right? So resultant is nothing but a plus B. So this side is A plus B, and this side is representing A minus B, negative of A plus B. Okay? So if you just add A plus B C, basically this thing, if I say this is the C vector, so A vector plus B vector plus C vector is equals to 0. Moreover, you can say that if it creates a cycle, if a complete cycle is there, then A plus B plus C, all the three vectors, if they are forming a complete set, the resultant will be 0. Is that clear? Understood? Okay. Now look, we were doing the addition of two vectors. How I will do the addition of more than two vectors? Just assume I have given one vector, and I have given another vector two. I have given another vector three. Okay. Let's add these three vectors. You know that I can align these two vectors such that I can go and I can say that okay, align. Let's align these two vectors in another format. So I will say that this is the alignment of vector, right? Tail, head, start of another tail, end of another tail. So can I say this? If I join the line of these two vectors, I will get the resultant of these two. So let's say I had three vectors. Okay? This is A vector, this is B vector, and another three vector is still there. Okay, assume in this form, something like this. Okay? Uh, let's make it like this, something like this. This is the third vector. Okay, made presented like this. So if I ask you, I need to get the A plus B plus. So can I say that instead of doing all the three like directly, let's calculate the A plus B. So when I calculate A plus B, I will get this as a resultant. So other is it an option for me? Now I can remove this AB because I am done with the AB part. Okay, I have calculated the resultant of this AB. Now I can simply add this vector with this. So this is AB, and I can see that the head of this is extending here. I can now forget that I had this part also. I can ignore this part. Okay. Now I can say that I had the third vector. I will take this third vector and align it with the resultant of AB. So you can see that what I am going to do, resultant of AB. Okay, so I think now it makes more sense. So you can see this is the resultant of AB. So you have got this as C vector. So you can see again, it is acting as a new thing. So this will be the resultant of A plus B plus A plus B plus. Same way you can do for multiple thing. Okay. Again, if I go with a new thing, let's say four vectors are there. This. If you have two vectors like this, I have four vectors. Okay. One is this way, another is this way, something like that. Another is pointing to some point. This. All are pointing to a single point. Okay. Basically, what happens is if they are creating a cycle, they will be pointing to a single point in a plane. Okay. There will be a point at which all of them are going to point to. So let's say this is the point I'm talking about. You can see all of them are pointing to this particular point. Now you can see I can align all of them in another way. What is that another way? I can go and say that this is the vector, okay, and this can be aligned as a this itself. Okay, here I'm going to make alignment. This vector can be done as this vector. I can go and say, and finally this vector I can say. Can I say all this thing? Better if you align it here. Okay? So if you see carefully what I am left with, you can say that, so this is the tail. If this is the head, if I join both of them, I will be getting the result. So what you have analyzed it, if you go if for any figure, start from any tail if you figure out, okay, which is not joining another tail. If you start moving, you can say, okay, this is a perfect circle, this is a perfect circle, this is a perfect circle, this is a perfect cycle. Here my cycle breaks. Here my cycle breaks. So this is my resultant. If instead of this, if the cycle would have completed, for example, you can simply say that this is A vector, this is B vector, this is C vector, not C, this is C vector, this is D vector, and the summation of A plus B plus C plus D, right? All these vector comes out as R. What if I do that? Assume this is the fifth vector. Okay. So can I say that A plus B plus C plus D and minus add of minus of R vector? What does this mean by minus of R vector? You know very well that minus of R vector is nothing but this. This is the minus of R vector. If you just put it over here now, which will complete a cycle like this. Minus of R vector, which is equals to E vector. Okay. So you can simply say that if you have five sides and they are forming a cycle, A, B plus C plus D plus E, this comes out as equal to 0, forming a cycle, a complete cycle. Okay? Complete cycle. And you know what? The summation of all gives me resultant. Resultant. What is the net effect? Okay. The net effect comes out as 0. So if a vector completes a cycle, it gives net effect 0. Effect of resultant equals to 0 is 0. Adit, just take a moment and let me know if you are done, like if you're clear with the things we have discussed so far, or have a doubt, we should discuss it again. Triangle slope of vector. Yeah, I can say that it's clear, right? A vector addition of more than two vectors. Look, this is a very important part of the discussion. So, if any doubt you encounter, uh, don't hesitate to clarify because when we will be solving the problems, this will be a problem. Okay, in that case. So, I can just go up the last part that is parallelogram law of vector. It's a very simple. Look, these triangles law of vector, parallelogram law of vector addition. Okay? All these kind of additions are just helpful for us to know that how graphical alignment looks like okay, when we solve it. So look, triangle law says that you need a two consecutive vectors and the third direction, the third vector will like if I make a third vector, it will represent the reverse is the represent the reverse basically the negative of resultant. So I can say that if it is A, if this is B, so the resultant of AB is nothing but A plus B. So this direction, whatever this direction is, this is representing the negative of R. Okay, so you can say that, okay, sir, this is representing negative of R. I don't want to make a triangle. I just want to know the resultant. So resultant will be looking like this. This is what we used to do in the case of triangles, right? Is this clear? The triangles law, which we did earlier. Yeah. Okay. Now, what does this thing, this parallelogram says are different? Parallelogram says that if you have two vectors and they are adjacent, basically, if two vectors forming two vectors are forming adjacent side of a parallelogram. These are two vectors forming an adjacent side of parallelogram. How? If you just extend, if I just make some one line parallel to this in this way, this is you can say a parallel line. You know, vector parallelogram will be formed like this. Okay? So you can say I can again join the rest of the things. These were the two main vectors, A vector and B vector. Okay, if they are two adjacent. Okay, look, these are adjacent, not the consecutives. Okay, if they are two adjacent side, then the third side, basically, the then the resultant of these is going to represent the diagonal. Okay, forming out of it. Meaning to say, this diagonal is going to represent the resultant. Is that clear? Resultant of it. So you can say that resultant is equals to, I will write a definition over this. So it's A vector plus B vector. Okay, that's the thing. So what does this law say is that if two sides, okay, if two vectors represent the two sides, two adjacent side of a parallelogram, then their resultant is represented by diagonal forming out of it. Okay, diagonal originating out of it. Okay, is this clear? This law. Basically, look, we have not discussed the proper calculation of triangles law and parallelogram right now. Okay, we will discuss that as a part of analytical method. Okay. Generally, what happens if you go into the book, they will do some calculation in triangles law of accreditation and parallelogram. We are not just doing that right now. Okay. We'll just discuss the crux. What is this? What is this? After this, we will go to analytical method. With that, we are going to do the derivation of the like how the things work. Okay. Actually, so that is the thing. So let me know if you're clear with all these laws till now. Done, right? Just a second. All right, so I'm coming to the new page. Let me know if you can see this. Okay, so here, the topic of discussion is analytical method, okay? Vector method by analytical method, vector addition by analytical method. Look, so far we have discussed how we can calculate values in graphical method. Okay? Now we are going to do it in a analytical method. We will properly forming equations and solve it. So how I can do this? Okay? So it's an easy way. We had two things to do. Okay, analytical method basically. What we are going to do, we will treat triangle law and parallelogram vector addition analytically to find a resultant of vector. So what I am doing is, I will do the first analytical method of triangles. Okay. Whatever we discussed in the case of triangles law, we will do the same for the by using analytical method. Earlier, I only said that this is a triangle, this is forming a triangle. Okay, so this will be resultant. But now we will be calculating the values, each values also. So let's do this. How the triangles law vector law look like? You know that in case of triangles, what we studied earlier. Okay, just let me know. Can you see the screen now? Sometimes students don't able to see the new page. Are you able to see the new page? Okay, fine. Look, in case as per the triangles law, I can say that this is my vector. This is my another vector, and you know this third side is going to be and my vector resultant is going to be represented by this thing, right? Okay. So this is one thing. Please note this one for now. This is A. This is C. This is O. Okay. Clear? And the vector you can call it as P vector, Q vector, and R vector. And these are some points we have to get it. Okay. That's fine. Now what we have to do is we have to calculate the value, but how I calculate? I can't say anything. Look, what if I try to extend this one such that I will extend it some value, but I will only take the value which is perpendicular. So I will just get the perpendicular out of it. So what is the perpendicular? I can say that this is my perpendicular value from here to here. Just drop a perpendicular to this. So, yeah, I can erase it. So you can see this is a proper thing we needed. Okay. All right. So if you see, can I say this angle is nothing but angle, some angle theta? Okay, this is some angle theta. Okay. You will get confused with this part. So I will remove this q from here. This is a vector q. Okay, this is vector q. This is p, and this is my angle small theta. This is my small angle theta, and this is point n. Okay. So first, let's go with the triangle CNO. You can say this is C, this is O, this is N, a bigger triangle. So can I say that in triangle CNO? Okay. Now from here, your triangle knowledge will be helpful. The properties of triangle, which if you don't know. In CNO, what is going to happen is Can I say that this CNO is nothing but a right angle triangle? In this right angle triangle, I can see that just magnitude. I am interested to know the magnitude. I am talking about the magnitude right now. OC as a magnitude will be equal to, because look, vectors we write with a cap, magnitudes we write just with the thing or either with the whole thing. These two are the representation of magnitude. So I am using this, okay, for simplification. So you can say that OC is equals to O1 square plus O of, what is the next? No, ON already did CN square, right? And you can say that this bigger of ON can be represented into two format, O to A and A to N. So ON I will represent O to A plus A to N square plus CN square, right? The reason ON is equal to OA plus AN. Is it clear so far?
Yes, sir.
Okay. So like next what I have to do is I will go into the another triangle. What is the smaller triangle? ANC. Okay. Look at the ANC. If you just go with the ANC in triangle A and C, what I can say that um, this is the theta, right? The angle theta, if you see, that is nothing but the sine theta. If I calculate what it will be sine theta, that will be C of n divided by the cube n, right? I can simply say that this C of n is nothing but q times of sine theta. Okay, and also what I can say that cos of theta, if you do, you can get that a of n is nothing but something around q, again the same thing. So what you are going to get, the an is nothing but q times of cos theta. Look at this. Okay, so now we have to substitute these things in my values. Okay, one more thing, what is OA? OA is nothing but the magnitude of P. So you can write this as P plus A of n is nothing but, I don't know, so I will write this as O A of n itself. I will put values on it. What is the Cn? I again, just whatever I know, I have already put the value. And O to C is nothing but resultant. Okay, so let's keep it as resultant square, resultant square. As per the triangles, now we got it. Okay. Plus Cn is also. Just put the values of this. So what you are going to get, the resultant equation 1. Substitute substitute in equation 1. What you are going to get then? P is still there, like that. Square was there. No, the whole of square is there. P plus an. What is the an? Q of cos theta, square of it, plus q of sine theta, and square of it. Square, square. Okay. When you just open this one, you will be getting p square plus q square cos square theta plus the another is 2pq of cos theta plus q square of sine theta. Okay. You can say that I will keep this together. So when you do this, you'll be getting p square plus q square as a common, cos square theta plus sine square theta. Look, this is just a calculation part, so I'm going a bit fast. If you still have doubt, you can just write it over there and you can see. This property is there that cos square theta plus sine square theta represents 1. So you can say that p square plus q square plus 2pq cos theta is equals to the resultant square. So you can say that resultant comes out as, the value of resultant vector comes out as p square plus q square plus 2pq of cos theta. Is this clear? Look at this, how we have solved the answer, how we have got the final value.
Yes, sir.
Okay. So finally, like in a better manner, if you want to write it, you can say that resultant vector magnitude can be called as under root of magnitude of p vector. Both things are all the same. Okay, it's just about the representation. So I wanted to give both of the representation to p vector, q vector, and cos theta. This is a representation. Okay. If I ask you what is the angle made by r with the mix p, okay, basically If I ask what is the angle this P was making with R, what is this angle? Can I calculate this B? Beta basically. I can right if you if I say that tan of beta, beta is angle between P and resultant R. Okay. P vector and resultant vector. So the tan beta comes out as I can say the R vector, basically the magnitude of R vector. If you could remember the magnitude and this. I don't get this. I'll say Cn divided by O n. Okay? Cn divided by O n. What is the Cn? Cn is nothing but we have already got the value from the top, that is q times sine theta divided by what is O n. O n already we had, that is P plus the magnitude of that plus q of cos theta. Understood? So like, you can see this is how we could have solved the things in very easier manner. In better, you can write it as q magnitude of sine of theta, p magnitude plus q magnitude of cos of theta. Okay, that's a all right. Let me know if you are done. Like if you don't have any doubt in this one. By this, we are completely done with the triangle's law of vector. Okay. Firstly, we discussed the graphical method in the previous page. Here we have discussed the analytical method. If you want to take a look, so this is the whole thing. Okay, just take a look and let me know. We should move further or have some doubts which we should discuss here. Other, let me know if is it clear. Here is, I'm going to the third page. There we will be discussing the final thing, that is parallelogram. Analytical method, analytical treatment of parallelogram law of vector addition. Okay. Again, as per the definition, I know one thing that if two sides, this is one side, if two adjacent sides are representing the, um, can I just go and get the vectors from there itself? This is go to the first page. I may try to copy this vector. It's seemingly good. I don't know whether it is can copy from. So you can say, as per the triangles law, we had this thing. Okay, we can increase the length of it. This side. So you can see this is the triangle law. Okay. As per this thing. Now what we need to calculate, we need to do analytical calculation. What I will do, the same method which I just did earlier. What, extend this baseline. Go to this baseline, try to extend it. How much you can extend? Somewhere till here, till you get the tip of that point. The same here also. Just take this copy, opposite manner. Should be perpendicular. Should be perpendicular. Should be touching this point. I need a perpendicular point. Now you can say this is a perfect quadratic vector. So what I will say again, the same way we have to do. A same way, exact same way we will follow. This is theta. I will call this as theta. So what are the points we can have is same points. I think we can take O, A, N, C. Okay? One extra point I can take here is B, because in the previous we don't have B. So you can see I have one triangle. Like I have multiple triangles in this particular case. Although important are just two or three triangles. Now, if you see carefully, should I do the whole thing? Look, if you see what I need, I just need the vector addition, right? All the part are same. All the part are same. Mean to say, in this equation, what they are going to say now? They will say that this A to C is parallel to A to. Uh, Basically, they will say that here. Just one more thing is that A to C vector is just parallel to O to B vector. Okay, or you can say that another way, because look, as it is parallelogram, opposite sides are same. Mean to say O of B magnitude is equals to A of C magnitude, which is equals to A magnitude. Okay, this is one thing. Another way is, and what they else they are to want to ask is, um, OB is also parallel to A vector. That's fine. Now I can say that instead of this A to C vector, this will work as a A vector form. Clear? And you know, if this is working as a A vector, the rest of the procedure is same. So I will go to this part and call it as, I'll go to the second page and get the whole as a method. Okay? Whole calculation, whatever we used to do in the previous case. Everything, exactly same. Everything is exact same over here. Okay? Some things will be different. I will write it. So that's the matter. So you can see it doesn't have any difference in this. Okay, the vector was same. What was the same vector? Um, okay, instead of this A, B, and Q, remove it from here. Call it as Q vector, and remove this as P vector. So it will be better to be matching the previous equations. Okay, now look what happens is, instead of this part, I can remove it again and then say that because as OACB is parallelogram, Q vector magnitude is equals to AC magnitude, and which comes out as, okay, that is fine, which comes out as OB magnitude, and you can finally say that whatever it is written over is Q vector is equals to AC vector. So wherever we are using AC, we can definitely use a word called this Q vector, okay, instead of that thing. So yeah, that's the thing. You can see we have done this part also. So we are done with the parallelogram of calculation. Is that clear? Should I discuss this in detail, or like we can work with it? Like now you can see that everything is same. This Q will be projected at here. So yeah, remove this A vector. It's not a vector anymore. You can see if like this is a vector, right? If I take this vector here, it doesn't make any difference because both have the same direction. This also have a direction, like this also have the same direction here to here, and magnitude. Because it's a parallelogram, if I place it here, it doesn't make any difference, right? So, and you know, if the configuration like this, I can directly use it with normal triangle plot vector, and the things will work the same. Okay. So just let me know if you're done with this part, or we should discuss it in detail again. Because a lot of special cases are there. If I just move it from here, so it would be better. Other, yeah, let me know. Should we discuss this in detail, or it's clear? I will say if you just read out the when I just give you the notes, now if you read all these notes, you will find out that it's a similar thing. It doesn't have any difference anymore. It's clear. Okay. Now I will move to the fourth page, that is where we will discuss some special cases. Okay. Acha. I will finally write a formula for two things. One is if you have a vector like this, I will write just a formula and we will go with the, because we have already calculated this formula from triangle's law of integration. So this is angle, this is P vector, this is Q vector, this is angle beta between the resultant and this. So what is this? This is the resultant. So what you can say that our resultant is nothing but P square plus Q square plus A, no, plus PQ cos theta and under. What is the cos theta? You can simply say that, so if I extend it a little bit, this is the cos theta. And theta is angle between P and Q. Because if you just write this vector P as here, okay, not possible. If I just copy, can I copy? Yeah, you can see this P can be placed here. So you can see this angle theta, whatever the theta is, here it was. Q vector. Okay? If you place it over here, this is the angle theta you are going to get. Theta. Okay? Same. This is Q, B, and direction is same. So you can say that angle theta is angle between P and Q. Okay. That's it. Now some special cases are there. What are those special cases? If the angle between them are zero, what does this mean? Case one, theta is zero. What does this mean? D 0 degree. When they are, look, this is the vector. Okay. This was another vector with some angle. When I said angle is zero, this theta, you can see this is the theta. This is going to be zero. It means it has been gone to zero. What will be my answer in that case? P square plus Q square. Let's write it here. P here, Q here, 0 degree. This is zero. Here to here, it's a 0 degree. So 0. So what is resultant equals to P square plus Q square plus 2PQ cos of 0 degree. Whole thing is under root. This comes out as 2, like what it comes out is P square plus Q square plus 2PQ. You can write this as P plus Q times of whole square. Under root is that, just cancel out. What you have got, simply just add both of them. This is the magnitude. Clear? Understood? Okay. So the next case is, okay. Next case is, look, I don't think I should discuss all these cases because cases are generally made of three angles: 0, 180, 90 degree. Okay? So let's do for 180 degree. If they are 180 degree, what does this mean? That one vector is in this way, another vector is in this way. Okay? I will just not touch it from the. This is the vector, and another vector is here, this one, in opposite direction. These two vectors were there. I'm just making head and not just, I'm not touching them so that you can make some difference. What is angle now? 180 degree. Okay. Theta is 180 degree. So you can say that R equals to P square plus Q square plus 2PQ of 180, cos of 180 degree. Cos 180 is nothing but -1. So you can simply say that what I'm going to get is p square plus q square minus 2pq can be written as r equals to p minus q square. This what we have got p minus q. Got it? This is the you can see, and in anti-parallel we used to get this kind of equation. Okay, in case of parallel we have got this equation earlier also when we don't know about these two forms. Third is 90-degree case 3. I will let on you to go through more. This theta if 90-degree, I will directly write the answer. Look, this whole thing will come up to 0. What you are left with p square plus q square. Resultant comes out as a square plus b square. This is the thing when both of the angle are 90 degrees. So that's the reason if you are given any Cartesian plane like this, x, like this is y direction, this is x direction. Okay, the vector should be this. So when I say about the calculate this, you know what we used to get the resultant, that was x plus y square, right? Because they were 90 degree. By Pythagoras also we got that r is equals to x square plus y square under. By this method also you are getting the same thing. Okay? If you do the thing like, okay, x square y square plus 2xy cos theta, theta 90 degree gets 0, the resultant is, so you have got the answer, right? So this is the thing so far we had to discuss. And okay, one more thing, how you will be doing the subtraction of two vector. So for subtraction of two vector, subtraction, same formula you have to use, just one difference is there. When I say a plus b, right? Let's say I'm saying of two vectors, a and b. So I will be saying that resultant is nothing but a minus b. Okay, I need a magnitude. What I can do is simply I can say that a vector plus negative of b. Now in whole time I can say the c is representing negative of b. So if you want to replace it, replace. Otherwise, in the formula also you can just go with the minus b vector. Okay? So you can say that r is equals to magnitude square. This comes out as a square plus b square. Yeah, the negative is there, so it won't make any difference to you. You can write it as minus ab and whatever the angle between them. Clear? This is how you can solve it. Is that clear to you? And I will say don't do this minus here. Like you can start with a minus, but here in the formula don't put negative here. Okay? Why? I will tell you. Put negative. Okay? Assume I am saying this is a vector I A, this is a vector B, and I told you to get me the subtraction of these two vectors. So you will say this is I, this is B. If I ask you what is the angle between them, you can say that is theta. So what is the angle between A and minus theta? Because here my another vector is B, right? And I have to put the magnitude. So magnitude always comes out positive, so this will always be positive, right? I don't have to put negative anymore. But what is the angle between A and B? Look, the angle between A and B was theta. So what is the angle between A and negative B? So you know the negative of B will be going like this, right? This is the negative of B. So can I say that this was the angle between A and B? This is the angle between minus. So this is the minus. What is that? 180 minus theta. So you can simply say that instead of putting cos sine theta, I can simply say that 180 minus theta. That is the thing. So yeah, just tell me if any doubt is there. Okay, 2 should also be there. I just forgot to keep it here. 2 should also be there. Let me know if you are done with the things. Any doubt is not there. It's clear, right? So yeah, that's all for the discuss from my end. If you have any doubt, you can let me know. We will end it by this. Just a second if I see some problem for you. Okay, just get me the answer for one thing that by this I will end the session. Problem 2. Given two vectors, vector force given to force represented by some vectors, maybe 45 Newton and 75 Newton. Force is a vector quantity, so you can assume it to be the thing. Let's not make the calculation complicated. So 10 Newton and 15 Newton. The smaller calculations, you don't have to go with higher multiplications, are acting at a 45 degree at a point in 45 degree to each other. What does this mean? 45 degree to each other. You have to get me the magnitude and direction of resultant force. Calculate magnitude and direction of resultant. One more thing, if you see in the earlier whole thing, we didn't discuss anything about the unit vector because we have got the beta angle. That beta angle is telling me what is the direction of this. Okay, so when I say one vector is this, another vector is this, so and resultant I used to calculate, right? If I get to know the beta, I can say that the resultant vector is at angle beta degree from P. Okay, so this is nothing but a direction representation. Okay, it's not that we all every time we have to represent r in the form of I and j itself. Okay, so you can represent that into the angle of theta. So yeah, you can solve this problem and let me know the final answer. Uh, okay, let's do it once. One thing, take it as your homework part. Take it as your homework, and I will put it so that you may have a time to read the whole thing, whatever we discuss. Then you can solve it. Okay? So it's your homework part. I can try to solve this one. If you have any doubt, let me know, or else I can just end the session by this. No, right? So by this we can end the session because okay. So goodbye and enjoy.